5 gives us a piecemeal function, or a piecewise function. F of x is 5x plus 3 when x is greater than 1, but it's 4x minus 1 when x is less than or equal to 1. We're asked to evaluate the function at some points, and in question 7 we're asked to sketch this particular function given in question 5. So first of all, to evaluate the function at x equals 1, 2 and 3, we just need to make sure we follow the right rule. Now when x is 1, we need to follow this second rule, because that holds for x less than or equal to 1. So 1 is less than or equal to 1, so we're going to follow the rule 4x minus 1. So f of 1 must be 4 lots of 1 minus 1. That's 4 minus 1, which is 3. F of 2, we have to follow the first rule, because 2 is certainly not less than or equal to 1. 2 is greater than 1, so we follow the rule 5x plus 3. So here, 5 lots of 2 plus 3, that gives us 13. So f of 2 is 13. For f of 3, we also follow the top rule, because 3 is greater than 1. So we have 5 lots of 3, add 3, which gives us 18. So question 5 is relatively straightforward. We just need to evaluate the function at some points. Question 7, we have to sketch the function. This is not as easy, but we can do it. They're just comprised of some linear functions, some straight lines. So first of all, let's sketch 5x minus 3, just the graph 5x minus 3. That's got an intercept of 3, and it has a slope of 5. That means for every 1 across, we're going to go 5 up. So for every 1 across, we're going to go 5 up. So it means it goes through this 0.18. It also will go through this point here, because for every 1 across here, it's going to go 5 up there. And so our line, I'll just get a ruler, 5x plus 3 is going to come down like this. It's quite steep. 5 is quite a steep slope. I'm just going to draw it dashed here, because in our split function, we don't want this whole line, we just want part of it. So the whole line looks like this. So this is y equals 5x plus 3. But we only want this line when x is greater than 1. So in fact, we don't want it when it's equal to 1, so there's going to be an open circle here. But we want it for all these values when x is greater than 1. So in black, I'm just going to draw this split function, y equals f of x. So we just take y equals 5x plus 3, but only for the values when x is greater than 1. So similarly, let's draw 4x minus 1. It's another straight line. It has a y-intercept of minus 1 and a slope of 4. So for every 1 across, we're going to go 4 up. So for another 1 across, we're going to go 4 up. So 4 is quite a similar slope to 5, slightly less steep. So this one's quite tricky to draw to make it look accurate. So these aren't parallel lines here. Tricky to draw without a big ruler as well. So this line is y equals 4x minus 1. But in our piecewise function, we only want to take that line when x is less than or equal to 1. So when x is 1, it's 3, and we want it equal to, so there's a closed circle there. But we want all the values when it's less than or equal to 1, which is here, and it's passing through minus 1 there. So our split function looks like this black curve, which takes on the graph 5x plus 3 for x greater than 1, and it takes on the graph 4x minus 1 for x less than or equal to 1. So we need to sketch each of them separately, and then only take the section that we want. Remember, we have an open circle when it's not included, or we have a closed circle when it is included. So that's the graph of our split function there.